Hello everyone, I'm Sichi. I'm going to take everyone through the 2018 Junior Kangaroo paper. So let's get started. With the first one, it's about calculation. So which calculation gives the largest result? So if you want to find them out, you got to get the value of them. So over here, there are lots of addition and multiplication. Of course, we got to follow the rule of bit math. And in bit math, the addition comes after the multiplication. So you always do the multiplication first. So with A, it's going to give you just like 2 plus 1 plus 8. That's going to be 11. And then with B, if you do the multiplication first, it's 0 for this part. As 0 multiplied by any number, give you 0. So you're just adding 0 and 1 and 8. That's going to give you 9. And then similarly, we can just do C, D, E. So with C, here is 0, so that's going to be 10. Here is going to be 8 for the multiplication. 2 add 8 is 10. And over here, if you do the multiplication first, 0 and then 8. And if you add them up, that's 8. So among all of these sums, A give you the largest result. So A is the answer. And now let's look at the second question. So which of the following expressions, when it replaces the symbol omega, makes the equation correct? So over here, I have a symbol, and with the equation, I have the symbol multiplied by itself, give you 2 times 2 times 2 times 2 times 3 times 3. So if it's something multiplied by itself, then you can just try to split this kind of product into 2 identical parts. So it's composed of 4 lots of 2's multiplied together and 2 lots of 3's multiplied together. So you can just split them in half, and you can have 2 lots of 2's multiplied with another 3. So in one group, you're going to have 2 times 2 times 3, and in the other group, you're going to have the same thing. So you can now say that, okay, so one of them as 2 times 2 times 3 would just be the value of our symbol. Okay, so as we are wondering, like, what kind of value can replace the symbol, we're finding the value of the symbol, then the answer would just be E. Okay, you just need to split them into identical parts. And now let's look at question 3. So it goes, which each of the designs show is initially divided into squares. So for how many of the designs is the total area of the shaded region equal to 3/5 of the area of the whole design? So we're looking for how many of them can give us 3/5 when you do the area of the shaded region over the area of the total kind of region. So what we do is we do them one by one. So with the first one, you see that there's 3 kind of squares that's being shaded, and then you can just divide it by the total number of squares you can see, and that's 1, 2, and then 1, 2, 3, 4 on each row. So 2 times 4 is 8. So that's 3/8, not what we want. Let's put across here. And then for the second one, you can also count. So it's a little bit obvious here. You can kind of try to make it more obvious, or you can just use your imagination. But basically, we have 1, 2, 3, 4, 5, 6, and 7, 8, 9, 10, 11, 12. 12 such squares that's been shaded. And in total, how many other? So on top of that 12, I have another 4 at the corners and another 4 in the middle. So you're going to add 8 to it. And that's in total 20. It doesn't matter how you count it. So that's going to be 20. And if you simplify it, you will see that if you divide both the top and bottom by 4, you're going to have 3/5. And that's what we want. So let's put a tick here. And then for the third one, so here you got some triangles, so let's split them all into triangles. So you would then have 1, 2, 3, 4, 4 of the triangles that's been shaded, and then there are 1, 2, 3, 4, 5, 6, 6 triangles in total. So that's going to be 4/6, and that's 2/3 after simplified, but that's not going to give you 3/5, so not what we want. And then for the fourth one, you actually do not need to count the squares. You can just look at how many rows are shaded, as like all of the rows are shaded, like all of the squares in a row is shaded. So in total, 1, 2, 3, 3 rows are shaded. And how many rows? 1, 2, 3, 4, 5. 5 rows in total. So that means 3/5 of the shape is shaded. And that is exactly what we want. Okay. And then for the last one, I have 1, 2, 3, 4 that's been shaded, and how many in total? 1, 2, 3, 4, 5, 6, 7, 8. So that's 4/8, and that's going to be like 1/2. So after finding out all of the fractions, we will see that only these 2 are kind of having 3/5 as a shaded fraction. So that's going to be C, the answer. Okay, so that's this one. And now let's look at question number 4. So here, Miller likes to multiply by 3, Abby likes to add 2, and Sam likes to subtract 1. So in what order should they perform their favorite actions to start with 3 and end with 14? Okay, so here, let's write down the kind of the operations. So Millie likes to multiply 3, Abby likes to add 2, Sam likes to subtract 1. And here you're starting with 3 and then end with 14. You can think, all right, if I start with multiply by 3, I'm going to have 9. But it's impossible to do anything to the 9 with what we have left to make it 14. So that means 3 multiplied by 3 is too early and it's too small. So that means we need to make this number larger so that we can make our product closer to 14. So therefore, of course, we wouldn't want to make it smaller. Then the next step would be to make it larger by adding 2 to it. So this step, you got 5. After you get 5, of course, you want to make it larger by multiplying it by 3, and that's actually going to give you 15. And after you get 15, how do you get to 14? You just subtract 1. Then perfect, we just use all of the operations of these 3 people. So let's double check. That's going to give you 5 times 3 minus 1, that's 15 minus 1, and that is 14. So in what order are we doing? We're first adding 2, so A goes first. And then we multiply 3, then it's Millie, and then minus 1, so it's lastly Sam. AMS is the one we're looking for. So out of all these choices, look at it carefully, C is the answer. Okay, so that's question number 4. Right, so for question number 5, here Emily has 2 identical cards in the shape of equilateral triangles. So she placed them onto a sheet of paper so that they can touch or overlap and draw around the shape she creates. So which one following is it impossible for her to draw? Okay, actually everyone, so for this, you can kind of imagine that she can do it like this, having part of it as like overlapping. For B, you can also kind of split them in this way. For C also, you can imagine how it works for D as well. However, for E, it's impossible for you to split them or try to kind of fit in 2 equilateral triangles. And actually, with 2 equilateral triangles, all of the angles, they are like 60 degrees. While for a rectangle, the kind of right angle is 90 degrees. So it's impossible without you cutting some of the angles to have all of the angles as 90 degrees. So E is the impossible one here. All right, so that's the first 5 questions. Hope it makes sense for everyone.